check a bit of a system here. So I will now talk about how to think like a polymath. Um, I don't really know if I'm a polymath, but I will still offer my insight and I will offer the thinking method that I have utilized across a lot of different fields. So, first off, what you need to understand is that no one, let me zoom on to this sentence, no one is going to help you out. Any project that you will be working on, well, generally in life, but maybe as a polymath, no one is going to help you out because if you are a polymath or a generalist, you will be working on multitude of projects, and unless you have good networking across fields, you will have to do it alone. No one is going to reward you. You have to be prepared for absolutely zero rewards, and for this reason, you have to have incredible intrinsic motivation. So without intrinsic motivation, you will not be able to get started on a project, work on a project, and finish that project. To get to get that intrinsic motivation, you must not, and I mean not, look at the complexity of the subject. It has to become something natural, intuitive. What do I mean by this? Well, for example, you are working on nuclear fusion. You must not be scared by the complexity of nuclear fusion because the goal is to produce, okay, and the goal of a polymath, produce original work with depth across fields. And to achieve that goal, you need for that subject to become intuitive to your mind. Okay, so how do I get started on being a polymath? Well, it's quite simple. It can be broken down into a few steps. First step is the hardest. Okay, so you start with a desire slash a goal. Problem is, framing of that desire or a goal is the hard part. Let's say neuroscience, right? Neuroscience, or farming. You want to produce an original work within that field. How do you get started? Well, first, you do not think in fields. Think in goals slash I don't know what is it, desires. Yes, think that you are part of a fictional universe. That's a pretty good way to get started. I think that's what a lot of world builders do, and generally a lot of good writers that are building up whole universes. You are part of a fictional universe, or make up some scenario. I mean, if you can't, it's not a problem. This is just so that you become more accustomed and more intuitive with the problem that you will be posing. For example, let's set a goal or a desire. It is, I want cheap food. I use this example multiple times, but I think it's the most understandable. So, you want cheap food or free food. Both are fine. Well, step number two. What are the what are the most intuitive constraints? For example, to get food, I know that I have to grow food. Problem. well, a constraint. I don't have a farm. So you do not have the surface area upon which you can grow certain amount of food which will sustain you. Why do I not have a farm? I don't know. Because, I don't know, I live in a flat. Good enough reason. Then you do the most intuitive solution to set constraint. For example, no farm, just plant something or buy a plant and put it on a windowsill. What does this mean? Is that you buy, for example, a pot of tomatoes. Put of tomatoes, put them near a window. Well, near a window. Bam, free food. Then you run multiple step 2 and 3, which is 2. What is the most intuitive problem, intuitive constraint against the most intuitive solutions? Constraint? We do not get enough potatoes, well, tomatoes, from simple pots near windows. Yeah, I mean, of course. Of course. I mean, you will not be able to get much food from a few pots that are barely alive from sunlight and, I don't know, barely fed by the rain. So, what is the most intuitive? What is the most intuitive way to solve that constraint? It is to utilize all available resources. I live in a flat, therefore, I might have a room which I don't need. So it is very important. I'm using food as an example and a flat, but for example, neuroscience, right? In neuroscience, you have to realize that you have a certain resource, for example, the brain machine interface has the ability to influence the brain's ability to think by these specific wavelengths of, I don't know, electricity. So you have that information, that incredibly important piece of information, which you can build solutions upon. Therefore, to utilize this feature, we utilize the third dimension within the room to stack the pots of tomatoes. Now, the most important problem, the most important part that will separate you from actual polymaths to just world builders that don't know what they're doing. Step 4. How do you realize this idea within reality? You have to apply this to all of your intuitive solutions, but for example, when you said that you were going to stack tomatoes, what do you mean by that? What do you mean? I'm genuinely curious. How are you going to stack the tomatoes? We know that stacked tomatoes equals tomatoes tomatoes collapsing because, I mean, a plant cannot support, for example, 1 pound of dirt upon itself. Therefore, we need something to support these tomatoes. Therefore, we need a structure. And that structure, that structure might be the scaffolding that I have lying around my flat. So now you already got to the part from I want cheap or free food where you might have already given up as, oh yeah, it's not going to work, to I am going to utilize the scaffolding within my house to support as many tomatoes as possible so that I get free tomatoes. Step 5. Now, this is where you go deep. This is where you get separated from actual researchers on frontier fields to just solving real world problems that you are facing. So, how do I maximize my desire? How do I maximize my goal? You apply the same basic constraints based on first principles, which are plants are too tall, plants can't support each other vertically, plants don't give that much produce, and plants don't like living indoors. These are already sub-problems which are engineering problems. How can you solve said engineering problems? Utilizing tools of genetic engineering. For example, make the plants more robust. Make the plants shorter. Make the plants produce more fruit or vegetables. And make the plants, I don't know, what more can you do to plants with genetic engineering? Make the plants less resource dependent. That's genetic engineering. Material science. How can I design cheap, lightweight scaffolding that will support as many plants as possible? Market research. How may I acquire these plants at the cheapest price? So you apply step 2 and 3 to these problems, then these constraints to solve your problems, and now you got from desire slash a goal. So the desire slash a goal was I want free food, and the end product is a study slash research on genetically engineered plants for indoor food production in non-optimal conditions, or um, the cheapest scaffolding to support as much weight as possible. This process, which was step 1 through 5, can be applied in any field, any field. For example, a field that I have no understanding of, quantum computing. I have no idea what the hell is going on in that field. Well, first off, the desire slash a goal. I do not even know what the desire slash a goal is in quantum computing, but to frame that desire slash a goal, we need to research most prominent problems. Or if said most prominent problems are too complicated for us to understand, we must learn first principles. First principles of quantum computing. First principles. You got qubits, quantum spin, noise, and some other stuff, right? So once you got the first principles down, you can then start framing some desire. Hold up. You don't actually need to know all of said first principles to have a design. You simply need to be aware how to connect quantum computing with something you want. For example, I want as many frames in Let's Play Minecraft, no, in totally not totally safe for work game um, using quantum computers. Now you begin working on first principles. So, first principles that you need to be aware of. You can, I don't know, you can even ask ChatGPT, like, don't use it if you are too lazy, I don't know, offload that thinking process to ChatGPT if you're lazy, but if you are not, you can do it on yourself and actually research what is a frame, how is a frame created, what is the process of creation of a frame within a quantum computer, why are quantum computers bad at generating 1,000 FPS in video games, and then you ask, how do quantum computers actually work? And based on that, you have now framed a problem, which is or a goal, which is using a quantum computers to generate logarithmic increase of frames on an OLED monitor based on new qubit architecture. And now you begin to apply the constraints and the most intuitive solutions, which is basic reverse engineering. But the framing of the problem is systems engineering as well, because you need to be aware of multiple different things, not only how the quantum computer works, but how it's connected. And that connection is the most important part. It's not only learning, because I have no idea about quantum computing. I mean, I said some things about quantum computing, but I actually don't know how any of this works. But because I know for sure what I want, and that is to use a quantum computer to generate 1,000 frames on a video game, I know which direction to take and which correct pieces of information to take that will benefit my quote-unquote research. Another important piece of information is that you need to be able to filter information. Because if you are a generalist or a polymath, you will probably be working on a lot of different fields across, for example, I have worked on 3 different fields in the last 2 months, and I do not have the ability to go all in depth because that is going to burn you out. And burnout, this is very important. Understand that your mind will burn out if pushed too hard. So well, that depends on how fast you're going and how fast you want to complete something, but you will burn out if you are going to dabble in or produce original work, conceptual or research type across many different fields. You are going to push your mind to overclock, and that will lead to a burnout. And burnout is a very, very, very big enemy against yourself, because it will hamper your efforts to do steps 0 through 5. Therefore, you must utilize as efficient of a system within your mind as possible. So, first step is to filter information and only learn / take in information that will benefit your subproblems. As we have said, step 2 to 3 is, and repeating step 2 to 3 is basically breaking your original goal to goals and sub-problems, and you only need to solve those specific targeted sub-problems to achieve your desired goal. Then what you also need to do is get feedback. This is very important. I haven't really gotten that much of a feedback. After all, I mean, ChatGPT is not really going to give you that good of a feedback because it's just very good at glazing you. So you want actual feedback. But you must understand that you want feedback from people who will not make you disillusioned. Because the worst thing that can happen to your mind is becoming disillusioned within the field that you have already worked on so hard. Therefore, it is important to ask right questions. Most people are siloed, which means that they know a specific problem and a specific set of first principles. Therefore, you must choose a sub-problem within your goal or project and ask people about that specific sub-problem and your most intuitive solution. Not drop your whole project and expect them to understand what is going on and help you to solve it. I mean, there are people who are going to help you out, but if you want to get the most bang for the buck from the internet, you, as I said, break it down to sub-problems and ask it on forums or on YouTube or anywhere that you might get an answer from. After that, after you have completed your quote-unquote research, to get a feedback, reach out to professors. Now, I don't know how much you will be able to do this, but for example, in my case, I don't have professors that work within nuclear fusion or antimatter research or other fields that I'm working on. But I'm pretty sure that if you're watching this, you have access to researchers and professors within this field. You don't even need university professors. You can ask a PhD student or someone that is curious slash some experience within the field that you have worked on. And after that, after you get that feedback, you must use that feedback to iterate your work. That is how you get depth. Yes, you can achieve breadth with my thinking methodology, steps 1 through 5, and you can achieve depth with feedback, because any idea is as good as the feedback says it is. Unfortunately. I mean, even if you solve a problem 500 years into the future of like using black holes for something, if you don't get good feedback now that says that you are not delusional and that what you have done is correct and is the correct approach to the problem and the goal you have devised, then that means that it is applicable to the real world. That is what you should be aiming for to become a true generalist or a polymath. Thank you for watching. If you have any questions, I am ready to answer them, and goodbye.